Hi y'all. In this video, we're going to look at the relationship between the converse, inverse, and the contrapositive, along with the original conditional. To do that, let's first determine which of the following are equivalent to if P then Q by making truth tables. And the three things we'll consider are if Q then P, which is called the converse, if not P then not Q, which is called the inverse, and if not Q then not P, which is called the contrapositive. And again, we're going to do this in a truth table setting, and I'm going to put these all in the same truth table, and we'll go through this together. As I see here, first one, I want to consider if Q then P. I have Q and P already in my truth table, so I can do if 2 then 1 in column 3. Alright, going through that. The rule for if then, again, is if the first thing is true and the second thing is false, the conditional in the if then is false, otherwise it's true. Alright, so again, this is equivalent to what's in column 3 of my truth table, and we'll come back to that in a second. Next, I want to do the inverse, so I need a not P and a not Q. I don't have that yet, so I'm going to put in column 4 not 1, in column 5 not 2, and then in column 6 I'll have if 4 then 5. Going through this, not 1. That should negate each thing in column 1, so that should be false, false, true, true. In column 2, I'll negate what's in column 2, that should be false, true, false, true. The if-then statement, I'm looking for where column 4 is true, and then column 5 is false. That should be the third row. Everywhere else it's true. So we're going to see that we put this in column 6 is the final result of the truth table we would get from the inverse. Looking at the contrapositive, which is not Q, if not Q, then not P. Well, not Q is in column 5, not P is in column 4. So this is if 5 then 4, which is in column 7. Looking at this, I want to see where the truth values in column 5 are true, along with the truth values in column 4 being false. That should be this second row right here. That's true everywhere else. We see this is in column 7. Re-examining my question, which was to determine which of the following are equivalent to if P then Q, makes me realize I probably should have a column for if P then Q. That will be if 1 then 2. This is the standard conditional column. So I'm looking again for where the first one is true and the second one is false. That's the second column. And it's true everywhere else. So, if I want to determine which of the following are equivalent to if P then Q, I'm comparing each of 3, 6, and 7 to what I have in column 8. Looking at 3, those don't match up. Looking at 6, those don't match up. But I see that 7 and 8 are the same. What that's going to tell me is that a contrapositive argument is equivalent to, this relationship is equivalent to the original conditional. One more time. The conditional is equivalent to the contrapositive, but not the converse and not the inverse. That's a very important fact and one we're going to use right now. To reiterate, we just determined the fact that if P then Q is equivalent to if not Q, then not P. Again, this is a contrapositive relationship. Let's use that to write the equivalent contrapositive of the statement. If it's raining, then it's cloudy. Here, I should notice I have two simple statements. It is raining and it is cloudy. The first statement, let's call that P. Second statement, let's call that Q. So the original statement could be written in symbols as if P then Q, which I know is equivalent to if not Q, then not P. So the equivalent contrapositive will be of the form if not Q, then not P. Not Q should be it is not cloudy, so I should write this as, if it is not cloudy, then not P, the negation of it is raining should be it is not raining. And that would be an equivalent contrapositive statement to the original. The next example we'll look at asks us to determine which of the following pairs of statements are equivalent. In A, the pair of statements are, if I show up to class, then I'll get an A, along with, if I got an A, then I show up to class. To break this down and make it into a doable problem, I'm going to take this, look at the simple statements. If I show up to class, I'll call that P. I'll get an A, I'll call that Q. And writing this in symbols, I'll see this can be written as if P then Q. Once I've done that with both statements, I'll compare them and determine if the relationship I see between them is equivalent. Looking at number 2, if I got an A, was Q, and I showed up to class, was P. I'll reiterate that the tense here is not going to matter in our understanding of the logical equivalence of the statements. That is, I don't really care that I went from I will get to I got. That's not going to affect how I'm going to view these statements overall. 2, the relationship is if Q then P. If Q then P. Looking back in my notes, I see this is a converse relationship. A converse statement is not equivalent to the original conditional, so these are not equivalent.